Hey everyone, so chapter 5 lecture, the title here is How to Code Control Structures. But for anyone who's ever sat through a lecture with me, I always like to start off a lecture with the importance of the topic. Years ago, I would be sitting in a class and my teacher would be lecturing and talking about a topic, and I found it difficult at times to answer why that topic was even important. Like, okay, I understand what you're telling me, and I can do the things that you're telling me to do, but I didn't grasp the big picture, like why. How to code control structures, I can tell you how to code them, right? But I like to answering why code them first. And if you understand the why we code them first, then you might be more interested in how to do it, right? So when you think of the good old who, what, where, when, why, if you can see my small type there, if you think of those questions, why is many times the most important, why we do what we do. Why things are the way they are or whatever. So I'm going to open up Word and I'm just going to type a little bit here to answer that question. Why code control structures? I'm going to zoom in a little bit here, maybe increase the font. Okay, and what are control structures is another question, right? Who, what, where, when, why. And I can answer what control structures are, and I definitely will do that. But let's start with the why. I think the why is the most important. The answer to that question, why code control structures, and these are very common things in applications. The answer to that question is that control structures make our programs smart. That's the best answer that in my experience, like the most concise answer that I can give is to why we do that. Which kind of implies without control structures, our programs are kind of dumb. It kind of implies that, right? But I'm not going to say that, right? We're just going to stick with the positive. Control structures make our programs smart. Now let me get into what that means. Okay? As human beings, we every day we make decisions based on conditions. All right. You all made a decision this morning already. I know the decision that you made. Okay? As an example, your alarm clock went off at 6 a.m. and you decided to get out of bed based on the condition of learning something in class. And being marked present. All right. So the decision was made to get out of bed. Now you could have decided alternatively to turn off the alarm and go back to bed. In fact, some students might have done that today. Okay? Then they're missing out, right? But you as a human being made a decision based on a condition. This makes you smart. Being able to decide what you're going to do, what is going on in your life based on a certain condition, allows you to make smart decisions, or maybe not smart decisions. It could allow you to make, the wrong decisions, which we do too. Humans make bad decisions. But regardless, they make decisions based on conditions. Okay, so that's conditions, period. Okay. I'll give you another scenario. All right, and I kind of talked about this the other day. Here's another scenario. And I talked about this the other day in lecture. An alert went off on an individual's watch that notified him, that told him to call 911. Got a iWatch. I told you this the other day. The watch told him to call 911 based on the condition of low oxygen levels in the blood. So I guess what I left off, he decided to call 911 based on the condition of low oxygen levels, which saved his life. So an individual made a decision to call 911 based on the condition. The watch was smart enough to censor, I think it was oxygen levels. It might have been something else. It might have been a combination of factors. I don't know if your watch, I think an iPhone can read oxygen level. I don't know what kind of sensors it has, and I don't know how that works. But it was a pretty smart watch, right? So these are a couple of scenarios where, as human beings, we make decisions based on conditions, and those decisions we make can be smart or they can be dumb. But the idea is we try and make smart in an individual's watch. Okay? So now, I guess, thinking of that, right, I'm going to ask the class, right, can you think of some other scenarios? Can you think of some other scenarios where you made a decision in your life based on a certain condition? Okay? Based on a condition, you made a decision. So that's kind of like, I'm just throwing, can you think of a scenario? Because I'm sure there's other scenarios out there where you can think of, hey, I decided to do this in my life based on this. Okay, that's a good one. I stopped my car based on the condition of being safe at a stop sign, right? So the condition was to follow the rules of the road, if you will. And so you decided to stop your car so you don't wreck. So that's a good one. What's something else? Like, even like big picture. Someone else decided to speed based on the condition that they were not late for work. So you made a decision to go faster than the speed limit so that you don't, based on the condition of not getting fired or written up. Those are good examples. All right, you decided to hit the snooze based on the condition you didn't feel good. You didn't feel refreshed at 5 a.m. Right? These are all real world scenarios. You decided to do something Yeah, I decided to drink a cup of coffee based on the condition that I was tired. Okay, so what we're doing, all these scenarios that we're talking about right now, why we code control structures are so that we can let our programs make those same decisions. Okay, our programs can make decisions based on conditions, just like we do in real life. Okay, and by allowing or by coding our programs to do this, okay, our programs can be smart. Okay, if we code them in such a way that make them smart. Okay, again, if you code it, if you the coder code it wrong, you can unintentionally make your programs dumb. If you get what I'm saying, we have the opportunity to make our programs smart, but if you code them wrong, you can make them dumb. We'll avoid that. For now, we're just staying positive, right? So that's why we code control structures. We code control structures to allow our programs to make decisions based on conditions just like we do in real life. Okay? And in real life, that makes us, if we make the right decisions, that makes us smart. Or if we make the wrong decisions, those were dumb decisions, and our programs can make dumb decisions too. Okay? But they can make our program smart. So hopefully, big picture, we understand why we code control structures. Okay? The next question is, what are control structures? Okay? And we're going to get into this. They look like this. Control structures are if statements. If the condition goes in the parentheses. So the keyword is if. Okay? And the condition goes in parentheses. If the condition goes here is true, then you execute the code inside of the curly braces. Okay, so control structures, one control structure, and we're going to talk about two of them, is an if statement. And what you do is you put the condition that we talked about, all these conditions in the real world. If the blood oxygen level is too low, then notify the user to call 911. So if this is true, if the watch detects low oxygen levels in the blood, it's going to send an alert to the user right here inside of these curly braces. Okay? That makes the watch a smart watch. Not just a dumb watch, but a smart watch. Literally, all these things that we call smart refrigerators, smart thermostats, smart watches, smart cell phones. Okay? All these devices that are smart are littered with if statements. Okay? Every application that exists has these statements in them. Okay, maybe that's a little bit drastic, but you get the point. Okay, if statements are foundational to coding. They're in C#, they're in C++, they're in Java, they're in JavaScript, they're in Python, they're in PHP, they're in Ruby, they're in all the languages. Okay, if statements are foundational. If statements are control structures. Because why are they called control structures? Well, they control the way the program executes. Because if the oxygen level is not too low, then it does not run this code, right? So it skips this code, and it controls the flow of the program running. So it controls the flow of the program. All right. So that's why we code control structures. This is basically what control structures are. Okay. And then what this lecture is okay, let's get into actually coding control structures. Now this is chapter 5, so my coding is going to create a new project. We'll just do a GUI since we've been practicing GUIs a little bit. We'll put this on my repo. Yeah, while loops are still considered control structures. Yeah, there are more control structures besides if statements. Yeah, loops are also control structures. So these are conditional, like if it's a type of control structure, conditional statements. So if you want to categorize these, they're just conditional statements. All right, so we're in the lab, chapter 5, demo 1. Just this is a text box for your blood oxygen level. Okay. All right. So conditional control structure. It's called conditional because it's based on, again, it's a decision based on a condition, aka the if statement. All right. So what I'm going to do is I'm going to read a variable out of the text box. I'm going to assume that you can give me a double or a float. We'll just do a float. We'll call this blood oxygen level equals, we're going to read it out of the text box. We're going to get the text property out of the text box. Of course, we have to convert this to a float. All right, we all did this. We're familiar with this process. This is the name of the text box. This is the text property of that text box. The text property is a string, so we have a string on the right and a float on the left. So those are incompatible data types. So in order to convert that string into a float, you do this float.parse. Now this slide talks about relational operators. Okay, an operator is a symbol like the plus, the equal. It's just a single symbol. It's a symbol that shows relation between two different things. So if blood oxygen level is less than, and I don't know what a healthy blood oxygen level, so I'm making this up. So the relational operator here is the less than symbol. Okay, these are our relational operators. Okay, they test, relational operators test a condition between two things. So the first thing is the blood oxygen level that we're reading from the text box. And the second thing is a value of 100. In fact, because I talked about this yesterday, you could take that number of 100, you could define that as a constant int called safe oxygen level equal to 100. And then you could just use the constant. So if the blood oxygen level is less than the safe oxygen level, do you see how that's more readable? Right? We talked about that yesterday in lab a little bit. How if this is a number that's not changing, you could document your code by just giving it a constant, and then that makes this line of code a little bit more readable. If the blood oxygen level is less than the safe oxygen level, label result.text is call 911. Else, now this is not a smartwatch, but you get the same functionality. Else, label result.text, you're good. Okay, now let me hold off on this else. We haven't talked about the else yet. Okay, so all we're doing right now is we're testing to see with this relational operator, we're testing to see if someone's blood oxygen level that they're going to type into the text box is less than 100. There's other relational operators. There's greater than, there's less than or equal to, greater than or equal to, or you're seeing if it does equal. Okay, now this is a relational operator, the double equal sign. Okay, this is commonly a mistake. A common mistake is to use a single equal sign as a relational operator. Okay, to test to see if one thing equals another, you need to test it with the double equal sign. Okay, so the double equal sign is a test. Double equal sign is a test to determine if things are equal. Okay, a single equal sign is an assignment. As in line 38, where we have a single equal sign that assigns call 911 into the text property of the label. Okay, so a double equal sign, that's your relational operator. Okay, so again, these are the relational operators. We covered them all. Oh, and then the not equal to. Not equal to is another way to test two things. Okay, but for our example, we call 911 if your blood oxygen level is too low. And if I say you got a blood oxygen level of 12, you'll see you get the result of call 911. Okay, now if I run this again and I give it a high number that's considered safe, you notice it doesn't do anything. Okay, so what happens if our blood oxygen level is not less than 911? It just skips this. It just skips the if statement. Okay, so one thing that when I was new learning programming, I thought, because look, we learned the if statement right now at 9:30 in the morning. At 9:40 in the morning, in 5 minutes, we're going to add more things to the if statement. And those other things are not required. And I didn't realize that when I was a new programmer. I thought, okay, if you're going to have an if statement, I thought that else that I had earlier, I thought that was required. I thought else was required if you had an if, which is just not the case. You can have an if statement by itself. If this is true, then it does this. So again, execute this code based on the condition being true. So the code, in other words, the code decides to run this based on a condition. You with me? As individuals, we decide to do things based on conditions. The code is deciding to run this based on a condition in the if statement. Okay, the condition is right here. Do you see where I'm highlighting it? That's your condition. Okay, if the oxygen is too low, that's your condition. If the alarm clock goes off, that's your condition. If you don't want to get written up at work, that's your condition. If you want to follow the rules of the road and be a safe driver, that's your condition. If you want to get stimulated by caffeine because you're tired is your condition. Take a drink of my tea here. All right. So this slide just gives a bunch of relational operators that can be used inside of an if statement. If the user's first name is Frank, if the text box is empty, if a string is null, if a discount percent is 2.3, if a Boolean variable is equal to false, right? These are just a bunch of examples that could go inside of an if statement. If the total is greater than or equal to 500, okay, now it has to be either greater than or equal to. If the subtotal is 500, this is still true because subtotal does equal 500. Okay, but if the subtotal is 499, 499 is not greater than or equal to, right? Okay. This is a single condition. This symbol right here is the and symbol, and we're going to code it twice. And we're going to add another condition. This is one condition. So if this condition is true, call 911. And unfortunately, in the real world, our conditions aren't always simple. Okay, the problems that we're solving, the scenarios are not always simple. Because the scenarios can be more complex, our code becomes more complex. Okay, so maybe in the real world, before the watch tells them to call 911, maybe in the real world, the oxygen level has to be low and the heart rate has to be high. So let's whoops, see what I did there? I'm going to remind you, if you accidentally create an event for like something you don't want to create an event for, right? A couple people did this yesterday. They accidentally created these events. Let me show you the correct way to get rid of it. You're going to go into the properties of the text box and change it to the events, and then go right here and delete the event this way. Okay, now I'm going to click Save All, and then I'm going to view my code, and you notice that event is gone now. Okay, that's the correct way to delete your event. I did not mean to do that, but I'm going to drag this over here. I'm going to call this my label for my blood oxygen level. And this is going to be a text box for my heart rate. The name of this text box is text heart rate. So heart rate, I think it's a whole number. So I'm going to do int heart rate equals text heart rate dot text. Of course, we have to parse it to an int dot parse. Okay, now we have a heart rate. So again, our blood oxygen level has to be low and our heart rate has to be high. safe heart rate. Yeah, I'm not sure what, I think under 200 we'll call safe. I'm not a doctor, don't quote me on that. So if the blood oxygen level is too low and we had a variable called heart rate is greater than the safe heart rate. $200 would be super high. 60 to 100 is the safe range from Discord. So we'll say that we'll keep it 200, just, whatever. All right. So now both of these conditions on both sides of the and side, they both have to be true on the left and true on the right for us to call 911. Now, you'll probably see this where it says could not copy blah, blah, blah. Do you want to run the last sit? No. What I'm doing here is it's already running. You have to close it, right? And then rerun it. Okay, so there we go. So now let's just say, okay, so my oxygen level is low. But let's say that my heart rate is good. Notice it doesn't do anything. I can click, 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 click. Again, it's just an if statement. We don't need anything else. It says call 911. So this side is true. My blood oxygen level is low, but my heart rate is not high. So this is false. So we have true and false. Therefore, the whole thing is false. You need both of them to be true. This needs to be true and this needs to be true for you to run this code. Okay? So as demonstrated, if I change this number to be a high heart rate, now it says call 911. So when you have an and, this is called a short-circuiting and. Okay, I could talk about what that word means, but this is short-circuiting and. Means both sides have to be true for you to run this code. Okay. The other operator is the or. Okay. Now the and is if you hold down shift and hit the number 7. That's the ampersand sign. Okay. The or symbol, this is called the pipe symbol. Okay. These right here, these pipes, if you look right above your enter key, right, you're going to hold down shift and press the button right above your enter key if you've got a standard keyboard. Okay, and that's the pipe symbol. So or works a little bit differently than and. In and, it says, okay, this has to be true and this has to be true to run this code. However, an or says, okay, if either one of these is true, then we're calling 911. So in this scenario, if you've got a low oxygen level or a high heart rate, you're calling 911. So it's obviously different. So in this scenario, if I say my oxygen level is low, but my heart rate is good, right? We're still calling 911 because only one of them has to be true. Okay, and they give some more examples in here. There is a not operator, and there is a single and a single or. The short explanation is you're always using double ands, you're always using double ors. They're called short-circuiting because they're just more efficient, and if that's a good enough explanation, I can go deeper, but for right now, let's just always use the double pipe and always use the double ampersand. They're more efficient. That's really just the rule of thumb. we don't necessarily have to go into deeper as to why that is. There's also a not, which is, you got to be careful with the not symbol, because it flips, it turns everything backwards. It says it reverses the value of an expression. So generally speaking, sometimes the not operator, you can't get away from it. Sometimes it's there for a reason. There are scenarios where you use the not operator, but it's also one that can kind of, generally speaking, it makes you do a double take. It makes you think a little bit more critically about the code. It's not something that I would say is intuitive, right? So we use iPhones because they're intuitive and easy to use. Okay, the not symbol makes something, it makes it not intuitive. Okay, so, this were to say, if the blood oxygen level is not less than 100, that's how you would kind of read that. So, like, if this were true, like, let's just say the user entered 90, okay? Is 90 less than 100? That is correct. So this would be true, but then not would reverse it. So originally this was true, not reverses it to be false. Okay, so in this case, you wouldn't have to write it this way. You could simply say, is the blood oxygen level greater than the safe oxygen level, and get the same kind of results. Okay, so if you can avoid using not, I recommend it because it's not intuitive. But there are scenarios where you do have to use the not to kind of flip the condition to the opposite. If it was true, then it becomes false. If it was false, then it becomes true. Okay, and these are called logical operators. Okay, so relational operators are your less than, your greater than, double equal sign. These are your relational operators, less than or equal to. Okay, those are relational operators. And then logical operators are your ands, your ors, and your nots. Okay, just the terms. Relational operators, logical operators. Okay, both relational and logical operators can be used inside of an if statement. And they can be more complex. You could have, again, real life scenarios can be complex. So you might have to say, and, another condition here. And age, bring that back. Let me say I can just define someone's age equal to 100 and age greater than 90. Okay, so 100 is greater than 90, so that will be true. And there's an order of operations that I want to show you here. So we see that the last part is true. So the blood oxygen level, let's say, is, again, these scenarios are a little bit, 100 is safe. So we want it above 100. So we'll say 101. So the blood oxygen level is good. The heart rate has to be above 200. So let's give it a safe heart rate of 100. Okay, we're not calling 911 here. I'm going to put a breakpoint in and actually demonstrate this. Debug, start debugging. So 101 is safe, heart rate is good. Let's click. I didn't know if it would go into, no, it's not going to go into each piece. So age is greater than 100 is true. You know what? I'm going to come back to the order of operations. I think it's actually a little bit later on. The order of operations when we get into this. Okay, in fact, we're at 40 minutes into the lecture. I'm going to pause it here. What I wanted to do, I kind of started talking about order of operation beforehand. And I said, we'll come back to it. I was like, I can demonstrate this pretty quick. So I drew something up. I basically commented out some of the stuff up above. So we're not using the blood oxygen level anymore. And I'm just looking at this if statement. And so in this if statement, I have an or, I also have an and. And so this is the tricky one because most people think ors and ands would fall on the same tier of order of operations, which actually is not the case. The ands run first. So in order of operations, the ands have a higher priority than the ors. Okay, to demonstrate this, I coded this up. To demonstrate this, you run the and first. So the first thing that you evaluate is the and. The and has a true on the left and a false on the right. Okay, so you could just simply put in true or false instead of evaluating things here. You could just put in Boolean values, which is what I've done to simplify this. So we've got a true on the left and a false on the right. So what is the result of true and false? So that's my question to the class. The result of that right there that I'm highlighting is what? You just take a guess. You're either going to guess true or you're going to guess false.
False.
That is correct. Not sure who said it, but false is correct. Because remember, an and has to be true on both sides for it to be true. So what evaluates here on the and is a false. So then what we're left with is a true on the left or a false on the right. If you have a true on the left and a false on the right, what is the result of true or false? If you've got true on the left and a false on the right, the overall result is a true. Right? Remember, on an or, only one side has to be true for the overall to be true. Okay? So the result of this, it will be that the if statement ran. And if I run this, you can see the if statement ran. Now let's pretend that the and did not have a higher priority. If the and did not have a higher priority than the or, you would just evaluate this left to right. And so if we look at this going left to right, we have true or true. Therefore, what is the result of true or true? The result of true or true is true. That is correct. So we've got a true on the left. So we got a true here, true and false. What would be the result of true and false? You have a true on the left and a false on the right. The overall would be false. That is correct. Right? So if the and did not have priority, the overall would be false, which would mean that this else block would run. I didn't talk about the else block yet, but the else is the false block. This is the block of code that you run if this results in false. Okay? So this right here is something that is a little tricky to remember, because you want to think that ands and ors have the same priority, but they don't. Yes, parentheses can change priorities. So if you're not getting the result that you want, you could change it by modifying, parentheses. You could do this, right? And then you can see the else statement ran. So we just changed that by adding parentheses to make this run first. Okay? But assuming there's no parentheses, you can jokingly say, just throw parentheses at it until you get the result that you want. But that's not really something you should do. You should understand that ands have higher precedence or higher priority than your ors. Okay? Now, that just kind of leads us back into the else. That's where we left off on the lecture. The else is the false block. So before we didn't have an else. Before we just had an if statement, and we would run this code if this was true. Without an else block, there is no code to run if the condition evaluates to false. Okay? After the if block, you would just run the rest of the code under the if block. So you might have other code down here, maybe a while, I don't know, you might have other code down here, and that would just continue to run. Okay? But there is something called an else block. And what I want you to remember about the else block, this is the false block of code. So that if this evaluates to false, if this were to evaluate to false, you run this block of code when the if statement evaluates to false. Okay? So just remember the else block is the false block. Now, right away, we can get into some scenarios, okay? So there's one more thing, and it's really a combination of an if else, and then you throw on another if. Okay, here's a scenario that is very relatable to people. Okay, there's a temperature outside. Let's say it's a whole int temp outside equals, and it's pretty cold today, but for January, 30 isn't too bad. Okay, if temp outside is greater than 90, greater than 90, we wear shorts. Else, keep in mind that else is your false block. So if it's less than 90, we could say else if, we could have another scenario. Temp outside is greater than 50, wear pants. Else if temp outside is greater than 40, wear a coat. else, if it's anything below 40, wear a parka. A heavy coat. Yeah, and stay inside. There you go. Okay, so how does this run? This code says, okay, the temp outside is equal to 30 degrees. If temp outside is 90, greater than 90, that's false. Else if it's greater than 50, 30 is not greater than 50, that is also false. Else if it's greater than 40, that's also false. This is for every other scenario. So this else blocks means every if statement above it is false. So there are multiple possible outcomes in this kind of structure. So we went pretty quickly from just an if statement, which you don't need anything else. You can just have an if statement. But there's also an if else. If else is like true and false, right? If you just have an if statement, it's just a true block. If you just have an if statement, it's just a true block. An if else is like a true and false. So there's two pathways. One's true, one's false. This one, there's multiple ways, there's a better way of saying it. There's multiple ways through the woods, but you're only going one way. There's only one outcome. You're either wearing shorts, or you're wearing pants, or you're wearing a coat, or you're wearing a parka and staying inside. Okay, you're only doing one of these things. Maybe you should also, if you're wearing a coat, I'm going to go ahead and say you should also wear pants. You need both. But that's... So... The real world is more complex than simple if statements, right? The real world, you might have multiple possible outcomes. But the point that I want to make here is you're only doing one of these things. Like you're not wearing shorts in this case and wearing a coat. If it's above 90, like let's say 100, let's do a... You're only doing one thing. It's not doing multiple things. All right. And you could see they kind of show you an if, else, if here. Again, I realize enough. I've taught this enough. Let me take a step back here because I feel like I've just dumped a whole bunch of new stuff, especially on the new coders, okay? Here's something that you have to realize. To truly understand and learn this, learn if statements, which includes if else, it includes if else if, else if, else. It includes something we haven't even talked about, nested if statements. To truly understand this, here's the facts. You have to do it. You have to do it. All right? If you've ever played a sport or if you've ever played a musical instrument, or you've ever taught yourself, or learned anything, let's just say play a sport, okay? I played basketball growing up, and I could have a coach tell me how to shoot a free throw by bending my knees, bouncing the ball a couple of times, flicking your wrist towards the basket, right? You need a good arch on the basketball. It needs to arch up, and by shooting it, it's going to arch up, and you're going to understand it needs to have a certain sort of arch on the ball, a rotation. You don't want it to rotate too much or not enough. You need a rotation on it. You understand all these things. But to get good at shooting free throws, you need to step up to the free throw line and do it often, many times over, days on end, months on end, and coding is absolutely 100% that way. Like, I can describe and I can show you how to do it, but until you actually do it, which is the whole point of labs, until you actually do it, it's going to get kind of hard to really understand all of this. You might go, okay, I get it. I think I got it. Okay, you lost me there. Okay, maybe I got that. You really got to code it. Where do the semicolons go? No, semicolons don't go there. That breaks things, right? Where do the quotes go? What does this error mean? If I don't capitalize this, what does that error mean? You really, some things in life you can learn through others. Some things you have to experience. And coding, to learn coding, it is absolutely something you got to experience. Okay? So we've talked about ifs. We talked about if-elses. Drew, do you have a typo on that? I don't recognize it. So if it is a thing, oh, different language maybe? I'm assuming so. All right. So that's, again, this block of code, there's only one way through it. Now, all right, here's a question I'm going to ask the class. Okay. I'm going to bring back my scenario from earlier. I'm going to comment that out. I'm going to bring back my scenario from earlier. Let me uncomment this out. If you guys remember, this was the blood oxygen levels, right? So I've got my blood oxygen levels, call 911. I'm going to get rid of this age thing here because that's where I was going to start to do. I was going to start to do the order of operations with that. But okay, simplify this. We got this or that, call 911. Okay, let's not worry about the age for right now. Okay. Let's go back to the and, because originally this was and. Both of these had to be true. True and true to call 911. We can write this a different way. I'm going to take this heart rate. I'm going to say if the heart rate is here, this is now nested. Look at this scenario. Okay, if the blood oxygen level is less than the safe oxygen level, it goes inside of the if statement. See how these line up? And then it tests if the heart rate is less than the safe heart rate, call 911. Okay, so if you have an and, like we had, I removed the or and I made it an and, you could write this way. Functionally, it's going to do the same thing. So you could write a nested if statement that would replace a double and. Why would you do that though? Well, this is actually kind of interesting because now we can write an else statement here that would be the false block for blood oxygen level. And here, this would be an else block for the heart rate. You see how I kind of line them up? So this else block could be label result.text, blood oxygen is safe. And this would say label result.text is heart rate is safe. So if the blood oxygen level is safe, it just prints it out, blood oxygen is safe. But if the blood oxygen is dangerous, then it tests the heart rate. And if the heart rate is safe, it'll print out the heart rate is safe. But if both of them are, if this is true and this is true, then it calls 911. So by adding nested ifs, what this allows you to do is have more scenarios. You can have more output scenarios, if you will. Because if you had this in an and, right? Here there's 1, 2, 3 possible output scenarios, the way I have this coded. If I undo all this, I'll bring it back to the and. I had 3 scenarios there. Let me bring all this back. Okay. Now we don't really know which one of these. But now there's only 2 potential outputs. Right? So that's really the benefit of doing nested. By having nested if statements, it kind of allows you to have more potential outputs, more potential scenarios as how you go through. So if I run this, so let's say my oxygen level is safe because it's 150, but my heart range is out of whack, 250. It'll say heart rate or blood oxygen is safe. Whereas if I drop that down to 99, this should say call 911. And those are my 2 outputs, right? When you just have an if-else with a compounded statement here. Okay, so that's your nested if statements. So we've actually, there's been a whole lot of new stuff this chapter, especially for beginners. Okay, if you've seen this once before, the second time you see this, it's a lot easier. I always say this is like addition. The first time you see it in like first grade. I'm assuming you guys all saw addition in first grade or thereabouts, right? You saw addition in first grade and you're like, whoa, what is this? Or maybe division. We'll say something a little bit harder than addition. You saw division the first time in first grade and you're like, whoa, that's complex. But then you saw it again in second grade. You saw it again by third grade. And by the third grade, you had division down, right? But the first time you saw division in first grade, you were a little intimidated by it, right? Division was hard the first time you saw it. If statements are the exact same way. The first time you see it, you're kind of like, whoa, this is kind of challenging. I've never seen this before. It's pretty hard, right? That's your first semester at Rankin, maybe, okay? Your second semester at Rankin, you see if statements again. So some of my class is in their second semester and they're going, okay, I kind of had it first semester. I kind of missed some concepts, but, I'm going to get it a little bit better this time, right? Right? So that'll be everyone at some point. They'll be in their second semester. By the time you're in your third semester at Rankin, if statements will be like, okay, I got that. I'm ready to move on, right? And that's when we cover more advanced topics, okay? So some of you are seeing this for the first time, and you're probably a little bit overwhelmed, and that's where we're going to practice and practice and practice. If you're seeing this for the second time, you're probably going to start to get into a rhythm with this, and it's not going to be so bad, And maybe some people at this point are like, okay, I got it. I'm ready to move on. And that's great. We're going to do some practice then for you. And that's exactly where you need to be kind of going into next semester. Okay. The last concept in this chapter is also a control structure. The switch is a conditional control structure, just like an if statement. Okay, an if statement can be kind of complex to understand when the scenarios are complex. Okay, you get into these scenarios where if this, else this, else if this, if, else, if, else. By the way, when you have an else by itself, there's no parentheses. Okay, if you have an else if, there is parentheses, but if you have an else by itself, that's the last else. There is no else if at the end. Just an else without parentheses. Okay, these if scenarios can be complex. Okay, when you've got complex real world scenarios that you're solving, these can get complex. Okay, so a switch statement is meant to simplify your code. It's meant to simplify or replace an if, else if, else if, else. Okay, so pretty commonly we have these if, else if. They're without nested. Without nested. Okay, so this is a pretty common structure. If, else if, else if, else, right? And these else ifs can kind of go on forever. You could have, right? So this is pretty common, right? But the point of this, and I mentioned this before, there's only one way through this. Like there's only one output. Only one output here. Okay? So int age equals 12. If age equals 10, you are 10 years old. Else if age equals 11, You are 11 years old. Else if age equals 12, you are 12. Else, I don't know how old you are. Okay? So, we're testing a user for their age. We know that this person is 12 years old. We say, are you 10? Nope. Else if, are you 11? Nope. Else if, are you 12? Yes. So you would execute this line 94. Okay? Well, they made another structure besides this if, else if block that can do this, okay, which is called a switch. Okay, let me code this inside of a switch. Okay, I'm going to do the same thing, age of 12. Okay. I'm going to do a switch on your age. That's the variable that we're testing. Case 10. You are 10. Break. Case 11. You are 11. Keyword break. Case 12. You are 12. Keyword break. Default. I don't know how old you are. You always have a keyword break. That break means something, it's required. So after every case or after a default, you always have the keyword break. Okay, it's required in C#. It's not required in other languages, but it is in C#. And that just means you do not continue executing here. So label result.text equals you are 12. Label results.text equals I don't know how old you are. So if I click, whoop, I got to comment this out because I'm not reading the heart rate anymore. So all it's doing is it's coming down here, it's seeing the age is 12. It's switching on this. It's saying, okay, does age equal 10? No. Does age equal 11? No. Does age equal 12? Yes. So run this case. Since age equals 12, you run this, you are 12. And I need to comment all this out because it's no longer a thing. And there you get the output, you are 12. Now if I come down here and I say you're 112, now it says I don't know how old you are. So this default is the false block that is similar to the else block, the last else block. So basically, if it doesn't equal one of these up here, it'll run default. Okay. Now, something about switching, again, it's just another way of coding this, right? So if you want to code it with this, that will work. If you want to code that scenario with a switch, this will work. It's essentially two ways of doing the same thing. Okay, arguably, once you learn the switch, it's easier to code, right? But, you know, that's an opinion. That switches are easier to code than if, else blocks. Okay, but there's a learning curve to learning switches. So it's not easier to code if you don't know it. It's only easier to code once you learn it, if that makes sense. JavaScript did have a switch. We just didn't cover it. That's my bad. Feeling a little guilt about that. As long as we're learning it at some point. There's a lot in JavaScript that we didn't learn. Can you do more than two else ifs in a switch? Can you do more than two else ifs? Yeah, so what you could do is you could do case 10, and if you really wanted to, you could. I've never done this, but I wonder, so what you're asking is, can you do something like here? Yeah. So we got, yeah, you can have inside of a case, you could have more conditional statements is essentially, I think, what Aaron was asking. Yep, good. Yep. Okay, now here's where you cannot use a switch. I'm seeing some, hey, I like this switch. This switch looks good. I like it. Okay. Switches are good in some cases, but not all cases. Okay. Switches are not good in all cases. Switches are not good for range values. Remember back at the beginning of today, we talked about our relational operators, and we can test ranges if the age is less than 100. If the age is less than 100, then you have to use an if statement. Okay? Switches are only testing one value at a time. So if you wanted to test if the age is less than 100, you'd have to have a case 99, case 98, case 97. Okay? So they're only good for testing one value at a time. So just keep that in mind. You know, switches are a little bit easier to code in some cases, but you don't use them in all cases because they're not good for ranges. If you're using a range, you want to stick to your ifs. Okay? And if you're newer in this class and you want to make sure you get your if else's down before you get your switches down, like, I understand that. Like, do one piece at a time. Okay, keep in mind you do have to have a break, and you can switch on more than ints. Like, what if I say char middle initial equals A? Now I can switch on the middle initial, and I would do case A, case B, case C, oh, Adrian, sorry, I overlooked. I didn't see your question. How would you do and statements or statements in a switch? Well, there's not. So I guess if you had to do an and, you would switch on the initial, and then you could do another. You could do another if statement here, in here, again, kind of more of a nested scenario. So there is no switch on middle initial, there is no and age. Yeah, that's not going to work. Okay, so to answer your question, the best way to do that is you would switch on middle initial, and then you would say if age is 112. So more of a nested type solution than using these logical operators. Awesome. Okay, now we're at a good point for a break. Okay, what we've got coming up next is different than our if statements. Okay, so this entire time so far, an hour and 20 minutes in, we've covered conditional control structures. Whether it's an if statement or a switch, those are conditional control structures. When we come back, we're going to talk about a different kind of control structure. Okay, that's the second half of this lecture. So let's go ahead and take a break.